Is 11:35, so let's go ahead and get started. Item number 1, I have two triangles butted up against each other, and I'm only giving you one length. All I'm telling you is that the line that's indicated there has a length of 14, that one of the angles is 60 degrees, two of the angles are 90 degrees, and two of these other angles are congruent. But because of what we learned yesterday about special right triangles, we know that there's enough information here to solve for x, y, z, and w. And it's highly suggestive, the order in which I put the letters on there, because that's probably the smart order in which to solve for them. So go ahead and solve for the letters in that order. And then item number 2, this is kind of a snapshot of relative positions of Sol, S-O-L, that's like the technical science name for our sun, the Earth and Mars. And the sun to Earth distance is 8 light minutes. This is to say that when light leaves the sun, it takes 8 minutes to travel to Earth. Mars is further away. Mars is 11 light minutes away from the sun on average. So when light is sent out by the sun, it takes 11 minutes to travel before it gets to Mars. Light is not instantaneously quick. It has an associated travel time, and over large enough distances, those travel times are significant. So what I want to know is, right now, in the way that I drew this diagram, how far is Mars from Earth? This is not a special right triangle question. This is a regular old question. Just do the Pythagorean theorem to get that distance, and I can talk a little bit about what light distance is. And then after we do this warm-up, we'll have this entire period to work on the review questions for, the homework questions for special right triangles. How's it going out there?
Good. You?
Good.
I'm all right. I need to go pick up my cat today at 2, so right after this, I'm gonna go out and grab him and bring him home. Only bummer is that, like, after surgery, pets are really fragile, so he's gonna be sad. We have to, like, keep him in his box, and he has to wear one of those dumb cones so that he doesn't mess up his stitches. But I'm sure he'll just be glad to come home today instead of being stuck at the vet. Also, during snack, I made avocado toast to munch on.
Same.
Oh, that's tight. Yeah, it's a good snack if you can get fresh avocados, but I didn't have enough time to eat it. So I'm going to mute my mic for a few minutes while y'all work on this so I can eat my toast without, disgusting mouth noises in the microphone. Because that is the worst. I hate listening to people eat. Okay, ready to go?
Yes.
Okay.
Yep.
So yesterday, based on special relationships used to build special right triangles, we were able to show that in these two good cases, you can relate all of the side lengths of a right triangle based on a single value, instead of like all of our other Pythagorean theorem questions, where we actually have to be given two numbers in order to calculate whatever that third number is. And so what we're about to show is that if we start here with 14 in this 30, 60, 90 triangle, that the number 14 is enough data along with these angle measurements and what we learned yesterday in order to build out these other four values. So if the hypotenuse of the 30, 60, 90 triangle is 14, in our setup, the way we did this in the notes is that the hypotenuse is 2L. What is L?
L is 7.
So we're saying here that if 2L is equal to 14, because that's the hypotenusal length, then L is 7, and that immediately gives me X and Y. So this is to say that X must be 7 because it's half of the hypotenuse, and Y must be what?
7 square root 3.
Yeah, 7 root 3.
7 root 3. So there's the first two answers. Now we need Z and W, and they're equal, right? Because we know that
Yep.
for our 45, 45, 90 triangle, both of these are just side length S. So solving for Z and W isn't solving for two things independently. You solve for one, you solve for the other. So Z must be equal to W, must be equal to whatever our answer is. And now that we know that the hypotenuse of the 45, 45, 90 triangle, that's Y, that's 7 root 3, how do we solve for S?
Can't we divide it by square root 2?
That's exactly what we're going to do. So the hypotenuse, because that's the shared side of these two triangles here, Y is 7 root 3. And if I want to use this formulation to get S, that hypotenuse is S root 2. So what I'm going to say here is that that unknown length, S root 2, we know it to be 7 root 3. I'm going to divide both sides now by root 2, by root 2, by root 2, by root 2. And so S is going to be equal to 7, that's not a 7, 7 root 3 over root 2. And before I move along, I need to simplify this. So what am I going to multiply it by?
By root 2.
Over root 3.
Root 2 over root 2.
Oh.
Root 2 over root 2 is equal to 1. So multiplying by this isn't going to change what the decimal is if we were to calculate it. It's just going to change the way that this appears. And so this is going to give us 7. And what is root 3 times root 2?
Root 6.
7 root 6. And what is root 2 times root 2?
2.
Just 2.
Yeah.
And so Z and W are both equal to 7 root 6 all over 2. And like I said, all of that comes from the fact that that one length I gave you was 14. That combined with the special right triangle rules is enough to generate all of these sides. And all of these sides are enough to generate the perimeter and the area and whatever other metric that you could think of. Yeah, whatever other metric you could think of for this original figure. And then item number 2, I bumped my plate. Item number 2, we're being asked here to solve for the distance of the Earth to Mars in light time. Now, if you don't know, I'm sure you all have heard the phrase light years before, either in some science, like pop science stuff, or maybe even science fiction. But even though the word that comes at the end of that is a measurement of time, a light minute, a light second, a light year, it's important to appreciate that those are not measurements of time, they are measurements of distance. Light travels at a constant speed, so if somebody says 1 light year, they are actually talking about the distance that light travels in the course of 1 year. So you send out a beam of light, you let it travel for 365.25 days, and then measure that distance with a meter stick. That will tell you exactly how far a light year is in exactly how far a light year is in meters. So here we want to do the Pythagorean theorem. Yeah? And what do we get?
You get the square root of 185.
Good. So this unknown length, c squared, is going to be equal to 11 light minutes squared plus 8 light minutes squared. So c is going to be equal to the square root of the sum of these two numbers. And 11 squared is 121. 8 squared is 64. 121 plus 64 is what again? What did I hear out there?
185.
Square root of 185 light minutes. And so c, that hypotenusal length, is approximately equal to, and I'm only going to turn this into a decimal so that we can talk about what this means, why we care. This is approximately 13.6 light minutes. So right now in this orientation, up here, this red dotted line, this is about 13.6 light minutes. Now, if y'all didn't know, electronic communication itself is light. Radio waves are a kind of light. So when you tune your car radio to a specific station, your car's antenna is actually picking up a specific color of light that happens to be transmitting music. When you make a text message in your phone and you send a meme to your homie, your phone is taking that meme and it's turning it into a light signal that is going to a local cell phone tower. That cell phone tower then rebroadcasts it to another cell phone tower closer to your homie, where their cell phone receives light from that cell phone tower, and that cell phone then takes the light and turns it back into whatever meme you were sharing. None of that happens instantaneously. It all happens at some speed. That speed happens to be the speed of light, and on Earth, the distances between us are so short that this happens so quick you basically don't notice it. But out in space, it takes a significant amount of time in order to relay messages. So let's say that you are an astronaut on Mars and you have an emergency, right? So you are here. Oh, by the way, did I tell you I got my astronaut candidacy notification? I didn't make it this time.
What?
Oh, you didn't?
No, I didn't. I got rejected again. It's fine though. I'm gonna keep trying.
Do they give you a reason why?
No, it's just the status in your usajob.gov account changes from submitted to rejected. But it's the same reason. I actually kind of guarantee I know why it is. They want pilots. They want people who already know how to fly a plane. So I think to have a serious chance moving forward over the next 10 years, because once I hit 40, I won't really have a chance anymore. I think to reasonably have a chance, I need to get my pilot's license as soon as possible.
Are you gonna get it?
That's an extremely expensive proposition, and if I have to spend $10,000 every time a cat needs a surgery, I won't be able to afford a pilot's license. But if I can get the money together, yeah, I'm gonna try and do it. Yeah. What else is there to do, right? Like nothing else matters. Hey, anyway, let's say that you're an astronaut and you're on Mars and you have an emergency, and you're like, hey, Houston, we have a problem. What should we do? How long is it going to take you to get help?
Couple minutes.
Oh, there's enough information here to tell me exactly how many minutes. How long do you have to wait to solve, or for Houston to solve your problem?
4 minutes and 27 seconds.
13.6 minutes.
So let's be very careful about this logic. So if Mars and Earth are both separated by 13.6 light minutes, it is going to mean that you're going to ask for help and you are not going to get a response for 27 minutes minimum. Here's why that is.
It's a lot.
You need help, so you get on the radio and you ask for help. That help is transmitted and it is light. Light carries that information back to Earth. So you're like, hey, help! And for 13 minutes, that signal is traveling to Earth. And it takes 13.6 minutes for that signal to get to Earth. So 13.6 minutes after you ask for help, people at NASA on the ground start figuring out what's wrong. They might talk to each other, but no matter what, that is also going to take a little bit of time, right? For the engineers on the ground to be like, hey, he's having this issue, here's how you fix it. And so after they figure it out, plus whatever amount of time that is for them to look up your issue in a book, they will then be like, hey man, we solved your problem, here you go. And then they send that radio transmission from Earth back to Mars, which again has to traverse this huge distance through outer space. It's going to take another 13.6 minutes.
They'll
And
be
so,
dead by then.
for you to get help, it is going to take a minimum of 27.2 minutes, plus whatever amount of time it takes them to figure out what your issue is. You are going to be anywhere from 30 minutes to maybe even an hour without assistance, which is why for going on long space flights like this, it is crucial that we send people with everything they need to solve their own problems, because you're so far away, there is no help, period. Also, just for context, in terms of light distance, y'all want to take a guess as to how far away the moon is?
Isn't it like close?
The moon
It's
is very
like 1
close.
light minute or something.
Not
Probably
even.
half a light minute, because if it's 8 light minutes from sun to earth, it has to be less from the
Oh yeah, way less.
Yeah,
Compared to the
yeah.
distance between planets, the Earth is, I'm sorry, the moon is basically in our backyard. The moon is only 0.2 light minutes away from Earth.
So
I'm sorry.
It takes like 3 seconds to get to radio call.
1.2 seconds.
So
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 if you're on like the moon and something goes wrong, and you like call the space station or something, then it'll take like 2.4 minutes.
no, seconds. So if you were on the moon
Oh.
and you had an emergency and you radioed back to Earth, it would take 1.2 seconds for NASA to get the message, and then it would take 1.2 seconds for them to get the message back to you, which, you know, doesn't sound like much, but that still means that every single time you are communicating with somebody on the ground, either in Houston or in Florida, you get on the radio, you're like, hey, what's up? Tick, talk, tick. Oh, nothing much. What's good with you? It takes a full round trip of 2 full seconds. It's like trying to talk to somebody. Like, you ever watch the cable news and there's a little bit of delay, so the conversation is awkward?
Yeah.
Same thing, except all the time, and there's no way to go around this. There is no way to make information travel faster than the speed of light. That's one of the fundamental rules of physics. Hey, anyway, just a little bit of slightly more interesting application. And I wanted to talk about a problem like this because in the second half of the chapter, we'll be looking at more interesting scenarios involving the distance between planets, just because I think this is an interesting way to think about distance, that the distance from the sun to the earth is actually 8 light minutes. And if you have all of these distances from the sun to various planets in light minutes, there are all sorts of interesting calculations you can do about the distance from one planet to another. Special right triangle homework is due tonight, and this time is yours to work on it. Once you are done, you may upload it, and that'll be it. If you have any questions, I'd be glad to go over them here in the chat on stream. And you should know that tomorrow is our singular most important lesson of the year. By tomorrow, please do have a scientific calculator or figure out how to get to the scientific calculator commands in your phone. That is just to say, take your calculator screen on your phone, turn it sideways, and that will give you access to sine, cosine, and tangent. And if you are not here tomorrow, you must look that video up on YouTube or look up some other video on trigonometry, because if you fall behind in trigonometry, not only will you suffer this year on this quiz and test that we're going to have over the next 2 weeks, you will suffer. You will suffer for the rest of your entire math and science career, which could be 3 years of high school, or it could be 3 years of high school and 4 years of college for 7 years of suffering total. Or if you go on to get a graduate degree in medicine or in science, you go for that PhD, you have even more suffering ahead of you than that. Everybody hates trig because it seems so like different and new or whatever. Nuh-uh. No, that doesn't matter if it's scary and difficult when it's newly introduced. You got to get it down now. You have to be able to do this stuff even if you don't fully understand what it is that it's talking about, just because I guarantee this will rear its ugly head every year for the next 4 to 10 years.
Mr. Robinson, I turned in the homework.
Lit, you're good to go.
Yeah,
bye.
bye, Mr. Robinson.
Yep.
Yeah, bye, Mr. Robinson.
I
See you,
turned
Mr. Robinson.
See you.
Dang, I got a bunch of talented geometers, I guess. Yeah. Whenever you're done with the homework, feel free to head out. You have a nice day, and I'll see you tomorrow. And in the meantime, everybody else, just get it done. And if you have a question, holler at me. I'd be glad to work out a few questions here in the chat. It's literally what I get paid to do. And boy, am I be thankful to still be getting paid, even though I'm working from home. Because cats are expensive, man. So much money. But it's okay. I would pay all the dollars for my tiny cats. I would bankrupt the kingdom. Tiny cattos. Does anybody out there have any specific questions from the homework? I'll do them for you. I'll talk about them, any of that good stuff, or is it pretty straightforward? Or even if you don't need help with a question, if you just want to make sure that you're doing stuff right, if you ask me, give me a page number and then the question number, and I can just tell you what the solution is. In about 10 minutes, I'll probably read all of them out just for your guys' convenience.
So
Yep.
if it's a triangle that's like 45, 45, 90, the hypotenuse, is it s square root 2, or is that what it is?
Yes, for any 45, 45, 90 triangle, the hypotenuse is the side length multiplied by the square root of 2 to make it bigger.
Oh, okay.
Yeah. And kind of just for your own head math, you see the square root of 2 and the square root of 3 a lot. Not just here, but in the coming years, you'll see those particular square roots used a lot. Just because when you take something and you simplify it down, you often get a root 2 or a root 3 left over. It's a nice thing to have in your head that root 2 is about 1.4 and root 3 is about 1.7. So what it's saying when it says multiply by root 2 is it's saying make it 40% bigger.
Yeah. Okay.
So if that side length on the 45, 45, 90 was 10, how big would the hypotenuse be?
It would be 10 root 2, so
About?
40.
No, that's too big. That's times 4, 40% bigger.
Oh.
10 times 1.4 would give us back?
10.4? No, I'm doing this wrong.
14.
Oh.
All you do when you multiply a decimal by factors of 10, by 100, by 1,000, is you move the decimal over that many places. So to multiply this by 10, we move it over once. To multiply it by 100, we move it over twice, blah, blah, blah. So if you had a 45, 45, 90 triangle, and you knew that the side length is 10, you would know that that hypotenuse is 14 and a little bit more.
Oh, okay.
Is that okay?
Yeah.
Tight. Oh, also, now that we're all stuck at home, man, do I feel like the richest man in the world? Because I'm one of the last people who can still get a haircut. I'm so glad I learned to cut my own hair years ago, because it's been driving me crazy, and now I got a nice, clean, tight fade, and nobody else does.
So you cut it yourself?
Yeah, I always cut my hair myself. Yeah, that's why my haircut is fresh every 2 weeks. Because if I was going to a salon or a barber shop, man, I'd be broke with that schedule. So yeah, years ago, I taught myself to cut my hair in the bathroom. I got 2 trimmers and 3 pairs of scissors that I do it with, and I do it real carefully. And then after I do the sides and the top, I call my wife who like does the back because I can't see back there.
But it's like a lot harder on like long hair.
Oh yeah, I'm not saying it's easy or it's a good idea. If you cut your own hair, you are taking your fate into your own hands and risking it. And I guarantee, man, when we come out of this quarantine, there's going to be a lot of really bad haircuts of people being like, oh, I just shaved my head. I don't know. I couldn't figure out anything else. But yeah, this is easy. I fade it all with the same number, and then I fade the bottom a little bit. And then on top, I just cut it a little bit shorter, and I use texturizing scissors to remove layers. Yo, if you have like long lady hair and you can cut your own hair, mad respect. That's way more. I mean, I'm sure y'all have seen all the terrible videos of the girls being like, and now I'm going to cut my bangs. And then it's just a train wreck.
Yeah.
Big sad.
Everyone's gonna like. I know people, they dyed their hair red and now they look like old ladies.
Oof. Sometimes I dye my hair purple in the summer, but I always set it back to normal by the time school starts. Also, my hair is really short, so it really doesn't take that long to get all the purple back out. But yeah, I mean, I guess like today is the time to mess around with haircuts, right?
Yeah. What's the answer to number 4 on the first page?
That's the 45, 45, 90 with a hypotenuse of 18, yeah?
Yeah.
The side lengths are going to simplify down to 9 root 2, which is about 12.7.
Okay. But how do you figure that out?
So what we're doing when we figure that out, and I'll just draw it real quick for everybody's reference who might be watching this on YouTube after the fact without the worksheet right in front of them, is that I have a 45, 45, 90, this is x, this is x, this is 18. Now we could say that x squared plus x squared is equal to 18 squared. That would give us the same answer. But the goal here is to try and use the properties of special right triangles to make this work as easy as possible. So what special right triangles tells us is that this is S and this is S. And what is the rule about 45, 45, 90 for the hypotenuse?
That it's like S root 2.
S root 2. And so all we do is we say 18 equals S root 2 and then solve for S. To get S alone, I'm going to divide both sides by the square root of 2 by the square root of 2. On the right-hand side, these cancel. And so S is equal to 18 divided by root 2. This would give us the correct answer in decimal form. This is 18 divided by the square root of, 18 divided by the square root of 2. 12.7-ish. However, the way that they get 9 root 2 is by simplifying this. And when we simplify radicals out of the denominator, we multiply by a fraction, which is equal to 1. Anything divided by itself is 1. So this isn't actually going to change the value of the decimal, right? This is just going to let us rewrite this in a cleaner way. What is root 2 times root 2?
2.
So this is equal to 18 root 2 over 2. And what's 18 divided by 2?
9.
Equals 9 root 2. And if you're ever unsure about this stuff, just double check it with your calculator. That's why we have this stuff. Not just because we're lazy at doing arithmetic, but 9 root 2 gives us back literally the exact same decimal. There's no difference in them at any position. It's the same number. It's just that this is a more traditional way to represent the value.
Oh, okay. Thank you.
You're welcome.
Mr. Robinson, I'm done, so I'm gonna head out.
Okay, have a nice day.
Bye.
Bye. See you tomorrow. Or I guess I should stop saying that I'll see people later and just start saying that I'll hear them later. Heck, I will be right back. I have to go pick up my cat at 2, and when I go out, I obviously want my phone charged. My phone is at 5%, and I don't have a phone charger in my office. I'm gonna run out real quick, plug my phone in next to my bed, and then I'll be back. What have y'all two been up to when you're not studying?
Working out mostly. That's all I can do.
Yeah, that's cool. Have you noticed any progress? Do you feel stronger or healthier?
Yeah,
That's good.
cause I found a 2-week shred, and it's just it's a list of videos every day, and just do them.
Tight. That's awesome. Have you seen the have you? Ugh, my words. Have you done yoga?
Yeah, because after every day, it's cool down of yoga.
Oh, that's really good. Yeah, it's awesome to mix yoga into your workout. It's like a way that you can both work on strength and stretching at the same time is why that stuff is so good. Did you check out that app that I tried to tell everybody about? It's called Down Dog.
No, I didn't try that one.
I highly recommend you check it out because if you make the account with your school email, you can get a premium service, which gives you full access to all of the workouts, all of the customized options, all the way until I think July. Yeah, because they had a thing where they were like, hey, if you're a school, give us your school email and we'll make sure everybody gets free premium. So it's free. And what it is you can set the length of the workout, what you want the workout to focus on. You can even change the background music, which is kind of tight because some of the music on there is whack. And it will automatically generate the workout for you and automatically generate a video that's pretty well organized and easy to follow.
Yeah, I'll try it.
Yeah, might as well, right? What else is there to do?
I've gotten to the point where I'm starting to paint my shoes. And
Tight.
now, None of my shoes are a single color.
That's fun. The nice thing about being young is that, like, since your feet are still growing, you would have had to have thrown those shoes away at some point anyway.
Yeah.
But as somebody who's very much interested in basically, I expect my shoes to last forever, just because, like, now that I'm an adult or whatever, my shoes last. They actually do last forever, except for like running shoes, those get beat down, and skating shoes, those get really beat down. So those have to be replaced when the bottoms go out. But like my just walking around sneakers, since I have so many of them and I circulate through them, they honestly, they don't really age that fast.
Yeah.
So yeah, man, you might as well live it up while your shoes are disposable, because once you become an adult, you're going to try and make them last as long as you can.
But like I don't paint any of my valuable shoes. I paint the shoes that like I got for school, and now since school's over, might as well paint them.
That is very true, yeah, because like everybody, I don't know, everybody has the same 2 pairs of shoes for going to HBU for whatever reason, right? Everybody has all white Air Force Ones and plain Vans slip-ons.
Yeah, that's right.
Or not slip-ons, Vans low tops. And then aside from that, if you're feeling fancy, kids bust out their Yeezys.
I was never into Yeezys. They're not my type. They look
They look like what?
like camel feet.
Yes, I can definitely see that. Yeah. And I don't know, I guess it's just my lot in life since I like was a high school teacher before I took that year off or whatever. They're kind of prevalent now. 3 years ago when I was working at AGBU, when they like Yeezys were new, and even I was trying to get them just so that I could flip them on eBay. It was everybody. It was like 40% of the campus. Like it seems like they're everywhere now, but it was way crazier when they were new. It was so many more students, but most of those students, I guess, graduated and took them to college with them.
That's why I'm not like into the like new trends, because like eventually they're gonna become the old shoes that no one wants to wear, and then you're forced to wear them and just like throw them away.
Yeah, fashion is cyclical, which is why even if something stops being trendy, if it was expensive, instead of just like throwing it away or selling it, I'm prone to keeping that stuff. And I think it's most prevalent in the width of pants. So like when I was your age, the most popular jeans were skinny jeans.
Oh,
And I was your age in 2004. So let's just call that decade the 2000s. And then you have the 2010s, and now it's 2020. And then if you go back in time, you have the 90s, you have the 80s, you have the 70s, you have the 60s, you have the 50s, you have the 40s or whatever. So in this like in this middle decade here, like the 2010s, sorry, the 2000s, right? Like 2004, it was skinny jeans. But in the decade after, mom jeans got really popular. You know what I'm talking about? Like high-waisted but wide at the bottom. So jeans got wide again. And in the 1990s, they were hella wide because of this company called Jeanco, J-N-C-O. So this was wide jeans. In the 1980s, skinny jeans were popular. In the 1970s, it was bell-bottom because they were wide. In the 1960s, pants on suits were skinny. But in the 1950s, suits on pants were wide. So like, this is a straight up wave. Pants get skinny and fat, back, forth, every 10 years. So here's my fat prediction for this upcoming decade, which is off to a terrible start. Skinny jeans will get popular again, which is why I'm glad I kept all of my skinny jeans from the 2000s and fit all of them, I think. So it won't matter. I'm ready for when Urban Outfitters tries to convince everybody that skinny jeans are brand new and you have to come buy them.
because this last decade was like the 90s all over again.
Yeah, it was a lot of 90s nostalgia, but I think it's important to keep in mind that the way that they presented the 90s to all of you at Urban Outfitters isn't actually how the 90s looked.
Yeah.
All of that stuff is always like a rosy reimagining of what people remember the 90s looking like, but actually the 90s I would assert we're terrible fashion-wise.
Yeah, like the last decade was